Alright, in this video we're going to go over the material that you're going to need for quiz 2, and this includes converting among fractions, decimals, and percents, how to see if a proportion is true, solving proportions, and then going over the metric system. So first off, I want to go over how to convert between or among the fractions, decimals, and percents. So to convert a fraction into a decimal, we are going to simply do the division. So a fraction bar just means that we're going to divide. So for example, 4/5 means we're going to take 4 divided by 5. And when we're doing the division, if we're doing this by hand, we're going to put the 4 inside the box. We're going to put the 5 on the outside. And 5 doesn't go into 4, so that's why we need to have a decimal and then add some zeros. But 5 goes into 40, and that's going to go 8 times. And then we can do 8 times 5 is 40, and we get a remainder of 0 so that we know we're done. So 4/5 is the same as the decimal 0.8. We just, again, do the division. And your calculator can do this as well. If we have something like 2/3 as a fraction, and we try to do the division, we're going to see that 2 divided by 3, again, 3 doesn't go into 2, so we have to add a decimal. We can add on as many zeros as we need. 3 goes into 20, that's going to be 6 times, that's going to give us 18. We subtract, we get a 2, we have a remainder. You can't stop when you have a remainder, so we add an extra 0, bring the 0 down, 3 goes into 20, again that's going to be 6 times. And then we can see that a pattern here emerges, and we're just going to have 0.66 repeating. We can write this a couple different ways. You can write this with the bar over it. When you're typing your answers into the quiz, into Moodle, you're going to have to type it in as like 0.66 and then ... at the end when you want a repeating decimal. So that's how you take a fraction and make it into a decimal. Now, to go backwards to convert a decimal into a fraction, we're just going to read the decimal as the correct way. So 0.25, I say 0.25, but that's not the correct way. The correct way is this is 25 hundredths because the 5 is in the hundredth spot. And so if we write it the correct way, we have 25 hundredths, which means 25 over 100, which means then we can simplify this by dividing out by the greatest common factor, in this case 25, and it would reduce to 1/4. This also works if it's like 0.4. Okay, 0.4 that's not the correct way. The correct way to read this is 4/10. And if we write this as 4/10 and then reduce, we would get 2/5. To convert a decimal to a percent, we simply multiply by 100. And since we have a decimal system, this means that we're going to move the decimal place 2 places to the right and add the percent sign. So a quick example, if we have 0.75 and we want to turn that decimal into a percent, we're going to move the decimal 2 places to the right. It becomes 75, and then we add on a percent sign. The percent sign percent means out of 100. So this still means 75 out of 100. It's just written with a percent sign. And again, when you are typing these answers into the Moodle, make sure that you use the percent sign like this, which is the Shift and 5 key. So if you don't have the percent, if you just type 75, that's not the correct answer. To go from a percent to a fraction, remember percent means out of 100. This symbol that we use, it just started like out of 100 like this, and then they used to go out of 100 like this, and then the symbol just kind of evolved. So it first started just being out of 100, and then out of 00, and then the 2 zeros look like that. So that's how that percent sign came about. And if we're doing a percent like 30%, and we want to change this, we can write that as 30 out of 100, and then we can reduce it to 3 out of 10. So and then once we have it as a fraction, if it's out of 10, we can then change that fraction to a decimal. In this case, if we want to make it into a decimal, we could also just move the decimal 2 places to the left. So if you have a percent like 140%, there is no decimal here, so it's implied that it's here at the end. It's invisible. We can put it in there, and we can move it 2 places to the left. And 140% would be the same as 1.4. Let's go through a few more examples. Before we do, here's some common ones that you'll see most often. And the ones that, I recommend memorizing is this 25%. You see that all over the place. I've also talked about this 1/3, 0.3 repeating. That one you should kind of have memorized. 75%, that's 3/4, 100%, that's the same as 1. Okay, anything bigger than 100% is going to be bigger than 1. And another one that you should probably have memorized is the 2/3, which is 0.6 repeating, which is the same as 66.6 with a little bar over it, percent. So 2/3 is 0.6 repeating, or 66.6 repeating percent. So those are some common ones that you probably just should have memorized, and it'll make your job a lot easier. Okay, so here's some practice. The first two we're going to write as a decimal and use repeating decimals as necessary. So again, 2/5. If we do our division here, that says 2 divided by 5. We add on, and that's 5 goes into 20. That's going to be 4 times. So 2/5 would be the same as 0.4. 1/3, probably have that one memorized, or should have that memorized, but if you don't, we could do the division, and we can add on a decimal here. 3 goes into 10 3 times. That gives us 9, and then we get a 0 there, and you can see that it's going to be 0.3 repeating. Normally, you could just write it with a bar over it. Again, if you're typing your answers and you can't get that bar, you can just do the ... to tell that it's repeating. The next two we're going to write as a decimal. So these are percents, and we're going to change it to a decimal. So percent means out of 100, and we need to move the decimal 2 places to the left. So 0.2% is going to be, so in this case we have to add on some zeros here. That's going to be the same as 0.002. And you can check if we go back from the decimal to the percent, we move it the other way, 2 places to the right. So decimals and percents, 0.2% means 0.2 divided by 100, so it's going to get smaller. And so it gets smaller by the decimal, moving 2 places to the left. 612%. Now that's over 100%, so that's going to be over 1. There is no decimal here, so it's implied that there's an invisible 1 here at the end. And we can move that 2 places to the left, so it's going to be between that 6 and 1. And that's going to become 6.12 as a decimal. The next set here we want to write as fractions. Now 0.5 would be written or said as 5/10. And 0.5 is a common one, that's 50%. That's the same as 1/2. So when you're writing these fractions, make sure they're simplified. 0.6 repeating, that's going to be 2/3. 20%. 20% means 20 out of 100, which we can simplify down. 20 goes into both of those and reduces to 1/5. 32% means 32 out of 100. And then we can, what can we divide that by? Well, first we can divide it by 2. That gives us 16 over 50. And we can further divide it again by 2. That gives us 8 out of 25. And then they don't have any more common factors, so it's 8/25. The last set here we're going to write as a percent. And it says use repeating decimals when necessary. So here, this is a decimal. We want to write as percent. We're going to move the decimal 2 places to the right. Becomes 81, and then make sure to add on that percent sign. 4.04, that's more than 1, so that's going to be more than 100%. We move the decimal 2 places again to the right and add the percent sign. When you're doing fractions to a percent, you could either make those fractions into decimals and then to a percent, or sometimes you can just multiply it by 100% because that's multiplied by 1. And in this case, if I multiply by 100%, I can simplify this first. This is going to be 60%. Or again, if you do the division, 3/5 is going to come out to 0.6 as a decimal. And then you can move the decimal 2 places over, add on a 0 here, and again, you would get 60%. 1/2, That's a pretty common one. Again, we can multiply by 100%, and that's going to become 50%. So that's how you convert among decimals, percents, and fractions. The next thing I want to talk about is ratios and proportions. So a ratio is a comparison of two quantities using the same units. And so, for example, this says, in a sample group of patients, there are 15 men and 20 women. What is the ratio of men to women? So we can write ratios several different ways. We could write them as fractions, 15 over 20. We could write them with a colon, 15 to 20. Or we could write them with the word 2, 15 to 20. Okay. Usually when we write ratios, we want to simplify these. So, as a fraction, 15 over 20 can be written as 3/4. So we can say that the ratio is 3/4, 3 to 4, or 3 to 4 with the word 2. Ratios have to be in a specific order. So the number on the top is the first thing we're talking about. That's, in this case, it was men. So the number on top is describing men. The number on the bottom is describing women. So if we wanted the ratio of women to men, we would have to flip this around and write it as 20 over 15, which is going to be reduced to 4 over 3. So the order matters when we're setting up ratios. A rate is a comparison as well, but in this case, a rate is going to have different units. And again, we can write rates as fractions. You use rates all the time. You use rates when you are traveling in your car. You're using rates when you get paid. When you're traveling, you're going 250 miles, say in 4 hours. That's a rate because the units here, we're talking about distance. Here we're talking about time. We can think of that as 250 miles over 4 hours. Most of the time, we want to get down to a simplified rate. In this case, it would be 125 over 2. But a lot of times, we want the unit rate. And if we divide this out completely, we would have 62.5. And then we have miles on top and hours on the bottom. So we usually just say this is miles per hour, mph. And this is called our unit rate. A proportion is an expression, an equation, where we have two ratios or two rates equal to each other. And you're going to have to determine if a proportion is true. You're going to know that a proportion is true if both sides are equal to each other. And that means, like in the case of 3/6 and 1/2, one way to tell if it's true is reduce both sides here. So 3/6 will reduce down to 1/2. 1/2 is already simplified. So that's one way to determine if a proportion is true. Another way to determine if 3/6 is equal to 1/2 is to cross multiply. So if you take the 3 times the 2, the numerator on the left and the denominator on the right, 3 times 2, is that equal to 6 times 1? And in this case, you get 6 on both sides. So yes, this is a true proportion. I think I say yes or no on the quiz. So yes or true. Whereas 6/10 equals 10 over 15. This is not a true proportion. So why is that? Well, let's just put a little question mark here. We want to see if it's true. So is 6 over 10 the same as 10 over 15? Again, one way is just to reduce the left. That gives us 3/5. If we reduce the right, we can divide the top and bottom by 5. We get different fractions. So on one side, we get 3/5. On the other side, we get 2/3. Those aren't the same fraction. So we know that that's not a true proportion. Another way we could do it, again, is by cross multiplying. So if we have 6 over 10, and we want to see if that's equal to 10 over 15, we can do 10 times 10, and that gives us 100. 6 times 15, though, that's not 100. That comes out to 90. So 100 is not equal to 90. So 6/10 is not the same as 10 over 15. So this one is not a true proportion. You can use these same techniques when you are solving proportions. So we can solve proportions by cross multiplying. That's probably the easiest way to solve them. So for example, if we have 9/6 equals 3 over n, we can rewrite this. Take 9 times n, and that should be equal to 6 times 3. 6 times 3 is 18. And then after you cross multiply, you need to divide by the coefficient, the number that's in front of the n here, attached to the n. In this case, we're going to divide both sides by 9 because this means 9 times n, and we want to figure out what n is. We want to get it by itself, so we get n is equal to 2. In that case, it comes out to a nice number. And you can check, once you plug that back in, it should work back into the original. So you should be able to check, is 9/6 equal to 3/2? Well, if you reduce 9/6, you do get 3/2. So we know it's true. The next example here, 5/7 equals x over 20. This one's a little bit trickier. It doesn't come out so nice. We take the denominator times the numerator. We get 7x on one side. On the other side, we'll get 100. 5 times 20. And then we want to get the x by itself, so we divide by 7. In this case, we got x equals 100 over 7. And you would try to simplify your answers if possible, but in this case, there's nothing that goes into both 100 and 7. So that is how you can just write your answer. You could also write it as a mixed number, but I suggest just leaving it like that, just making sure it's reduced, and you can write it as an improper fraction. You could also write it as a decimal, but in this case, since we're dividing by 7, I think the decimal doesn't come out very nice. It's a repeating decimal, so it's easier just to write your answer as a reduced improper fraction. So here's some extra practice. Again, I'll just do a few more of these. We'll do the ones here on the left. So 4/2 and 16/8. Again, you could do this either way. We want to see if these are a true proportion. So 4 times 8 is 32. So we get 32 when we do 4 times 8. And if we do 2 times 16, we also get 32. So this one would be, yes, that is a true proportion. For number 3, we have 9 over 8 and 3/2. Are these the same fraction? That's basically what we're asking. 9 times 2 is 18, and 8 times 3, that's 24. Here we don't get the same number, so no, those are not, a true proportion. They're not the same fraction. And again, solving proportions. Here we're going to solve by cross multiplying and dividing. So here is the original problem. 6/8 equals 2 over n. We can do 6 times n. That gives us 6n. 8 times 2, that gives us 16. And then we want to get the n by itself, so we're going to divide out by the 6 here, and divide this out by the 6. So these 6's cancel on the left, and we have n, and then on the right side we need to reduce. What goes into both 16 and 6? Well, we can divide those both by 2, but we get 8 on top, 8/3. And again, I would just leave it as a reduced improper fraction. But this one, if you wanted to write it as a mixed number, let's see, 8 divided by 3. The 3 goes in there twice, because that would be 6, and then we would have 2 left over. 2 2/3 would be another way of writing it or saying it. Or if you wanted it as a decimal, you'd have to write it as a repeating decimal, 2.666 ... And for number 7, we have 7 over r is equal to 8 over 4. So again, cross multiply, that gives us 8r. And then on the other side, we get 28. We're going to divide both sides by 8. We've got r is equal to 28 over 8. And it looks like 4 will go into both of those. So we divide the top by 4. We divide the bottom by 4. And we're going to get 7 over 2. 7/2. Or again, we can write that as a mixed number. That would be 3 1/2. Or we could write that as 3.5. There, the decimal is a little bit nicer to write. And that's how we determine if proportions are true and how we solve proportions. Okay, and in this last part of the video, I'm going to go over the metric system. Now, here are some prefixes for the whole metric system. Well, not the whole. There's probably other prefixes here, but this covers quite a lot of the prefixes for the metric system, going up to the very, very big, like exa and peta. But some of these you probably have heard of, like tera in terabytes and gigabytes, mega. But the ones that you're going to have to memorize are the ones that I have outlined here, between kilo and milli. Again, you're probably familiar with some of these small ones like micro and micrograms, or possibly nano. When they talk about nanotechnology, they talk about very small things. And to help you memorize them, there is this mnemonic device: King Henry died by drinking chocolate milk. The K stands for kilo, the H in Henry stands for hecto, the D, the first D, in died stands for deca. The B in bi stands for our base units, and the base units that we're going to be using are going to be grams, liters, and meters. So notice the letters here. We got little g for grams, big L for liters, and little m for meters. And then the second D here, drinking, that's deci. Now we're getting into smaller units. Chocolate is centi, and milk is milli. So the base units, when we go this way, can't see that very well. Let me get another. So when we go up like this, we're getting 10 times as big each time. So, going from the base unit to deca, that's 10 times as much. Deca to Henry, that's 10 times as much. Henry to kilo, that's 10 times as much. And then if we go this way, they're getting 10 times smaller. So we're dividing by 10. So if you go down the list. So if you go up the list, we're multiplying by 10. And if you go down this list, we are dividing by 10. So here's a few to practice. And when I'm doing these problems, I like to write out the mnemonic device at the top here, and I'll show you how to use that. King Henry died by drinking chocolate milk. Just write out the letters. And here's how we're going to solve them. So here we want to do 30 centimeters to millimeters. So notice the little m here stands for the meters, and then we have to look at the prefix. So we're looking at the prefixes, and this one's going from centi to milli. So the ones, again, that we're going to use are kilo, the base units, centi, and milli. But you have to have this whole thing listed out here in order to convert among those four. So for this example, we're going from centi to milli. So notice that we're starting with centi, and we're going to milli. So that's going to be to the right one spot. And that's going to tell us how many places to move the decimal. In this case, there is no decimal. So we just write it here at the end, and we add on as many zeros as we need. We're going to have to move the decimal one place to the right because we're going again from centi to milli. And so if we move the decimal place one place to the right, 30 centimeters is going to be 300 millimeters. So when we look at our chart here, whichever way we move and the number of spaces we move, that's the exact same way that we have to move the decimal place. The next one, 0.03 kilograms to milligrams. So the G here stands for grams, and the K stands for kilo, the M stands for milli. So we'll go back to our chart, and here we're going from kilo, all the way to milli. So that's 1, 2, 3, 4, 5, 6 places. We're going to move the decimal 6 places to the right. So we're going to have to add on some zeros here. Let me put on some zeros here so we're ready to start moving. And let's move 1, 2, 3, 4, 5, 6. I added on a couple more than I needed to, but now we know that that's where the decimal place is going to end up. So 0.03 kilograms to milligrams is going to move over 6 spots, and we have the 3 here. We don't have to write the zeros in front of it. And we need to have a 0, 0, 0, 0. We need to have 4 zeros here, and that would be 30,000 milligrams. The next one, we're going from meters. Now this one doesn't have a prefix, so this is just meters by itself. And when we're talking just meters or grams or liters, that's in the middle here. That's the base unit. So the base, the B here, stands for meters, just plain meters, grams, or liters. And here we're going to go from 30 meters to centimeters. Okay, so we're starting at the B, and how many places are we moving? 1, 2 places to the right. So 30, there's no decimal here, so we have to introduce one. And we need to move it to the right 2 spots, so we have to add on some zeros. So we can move it over 1, 2 spots. And 30 meters is going to be 3,000 centimeters. All right, here in the next one, we're going from milliliters to liters. Again, the L by itself is our base unit. This one has a prefix of M, so that's milli. So now we're starting here at the end, and we're going to move the decimal to the left. So if we go from a smaller unit to a bigger unit, we have to move the decimal to the left now. So this one's going to move 1, 2. Let's start that again. This one's going to move 1, 2, 3. So it's going to move 3 places to the left. So here we have 300,000 at our decimal, and we need to move 3 places to the left. So 1, 2, 3. It's going to be right there, and we're going to get 300 liters. And sometimes you might have mixed units. So in this case, we have 3 liters, 200 milliliters, and we want to convert it all into milliliters. Well, so what we're going to do is, if we have mixed units like this, we're going to change the 3 liters into milliliters. So 3 liters means we're starting here at our base unit, and we want to go to milli, so it's going to move it 1, 2, 3 places to the right. There's no decimal, so we add a decimal. Move it 1, 2, 3 places to the right, add on some zeros. That's 3,000 milliliters. And now we know that 3 liters is 3,000 plus 200 milliliters is going to give us a total of 3,200 milliliters. So we convert the liters into milliliters, we add on the extra milliliters, and we get our answer in milliliters. And that's how we convert using the metric system. And this King Henry died by drinking chocolate milk. All right, so that's all I have for you for quiz 2, so hopefully that helps you out. This metric system you're not going to see on quiz 2, but you will see it on the first test. So that's why I'm introducing it here, so you can start practicing it as well. Let me know if you have any questions. Bye!